To complete the next example, you need to be able to answer this question. What is the most important component in a frozen dessert? Without this, it would not exist. Well, the answer is ice. To become a frozen dessert expert, you must understand its most important component, ice. This graphic displays the ice content of frozen desserts. On the far left, we have a glass of water with 0% ice. And on the far right, we have ice cubes at 100% ice. Then clustered around 50% ice are the frozen desserts that we enjoy. Ice content is a very important component that contributes to the mouthfeel and texture of a frozen dessert. And having the correct amount of ice is crucial. Well, what determines the ice content of a frozen dessert? Temperature, water content, sucrose equivalence. That is total concentration of small molecular weight ingredients such as sugar and corn syrup. And milk solids, not fat content, because milk solids, not fat, contains lactose and other milk salts too that reduce freezing point. Well, what is sucrose equivalence? Experiments have been done to determine the reduction in freezing point for a given concentration of sucrose. For a given ingredient in solution, the equivalent concentration of sucrose that would have the same freezing point, or sucrose equivalence, can be calculated. Sucrose equivalence allows the overall freezing point depression due to all the ingredients to be calculated. But do not confuse sucrose equivalence with relative sweetness. Freezing point is dependent on what is in the product. The smaller the ingredient molecular weight, the more effective it is at reducing freezing point. In this graph, you can see that salt molecules are much smaller than the other items listed. That's why its freezing point is so low. Salt is placed on the highway because it keeps water from freezing even at low temperatures. And the lower the freezing point, the lower the ice content. We can estimate the ice content of a frozen dessert if we know the amount of water and the concentration of sucrose equivalents. The estimated ice content is a key indicator of how a frozen dessert will behave during freezing, and it's useful for determining the expected mouthfeel and texture of the frozen dessert. In example 3, it'll be a situation where we know the composition and we need to develop a recipe. What are we going to do? We're going to reduce the fat in an ice cream from 12% to 3%. We're going to increase the protein content to 6%. We're going to determine what needs to be added to maintain the same ice content. We're going to compare freezing curves. Well, let's get started on example 3 in TechWizard. This example demonstrates an advanced TechWizard feature. We're going to reduce the fat content of a formula from 12% to 3%. At the same time, we wish to maintain the ice content and the sweetness level of the frozen dessert. TechWizard is going to help us accomplish this. We will be referring to the short course computer-assisted formulation handout that was mentioned in the previous example. First, we need to retrieve our 12% fat ice cream. Our new formula will need to match the sweetness level and ice content of this formula. You need to be in the formula development section. To go to the formula development section, click the Formula Dev and Batching menu and select Formula Dev from the View group. Click the File menu and select Open Formula. The Retrieve window appears. Select SC, EX3, Starting Formula, and click Open. Up to now, we have worked exclusively with data properties like milk fat. In this example, we will be working with complex properties. This is a very powerful TechWizard feature. A complex property is actually an equation. In this example, we will use complex properties to determine the freezing point and ice content of our 12% fat formula at 10 and 22 degrees Fahrenheit. Click the Add Properties button. The Add Properties window appears. Click the Complex Property tab. Select Freezing Point Degrees Fahrenheit and click the Add button. Select Product Frozen, grams of ice per 100 grams, T1, and click the Add button. Select the 22 degree Fahrenheit option and click OK. Select Product Frozen, grams of ice per 100 grams, T2, and click the Add button. Select the 10 degree Fahrenheit option and click OK. Close the Add Properties window. Notice that the relative sweetness value is close to 15. Most frozen desserts have a relative sweetness between 13 and 16. This means a sweetness level of between 13% and 16% sucrose dissolved in water. Note that there is about 46 grams of ice per 100 grams of mix at 10 degrees Fahrenheit. We need to rename this formula. Click the Formula Name and ID box. In the window that appears, enter 12% fat for the formula name. Click the OK button. We are going to transfer the formula information to another part of TechWizard, the Mixed Properties section. This will allow us to compare the ice content of multiple formulas. Click the Mixed Properties menu and select Get Formula Information. When prompted, enter 1 and click OK. This loaded the 12% fat ice cream formula in the first column of the Mixed Properties section. Let's go back to the Formula Development section and start work on our 3% fat formula. Click the Formula Dev and Batching menu and select Formula Dev from the View group. We need to modify the property ranges before TechWizard can create a 3% fat formula. For the property milk fat, enter 3 in the minimum and maximum cells. Let's go down to sucrose and delete the values for minimum and maximum. Next, go down to relative sweetness and enter a minimum of 15 and a maximum of 15.5. All these values are listed in Table 7 in the handout. Click the Formulate button. We're going to rename this formula, load it in the Mixed Properties section, and review what just happened. Click the Formula Name and ID box. In the window that appears, enter 3% fat for the formula name and click OK. Click the Mixed Properties menu and select Get Formula Information from the Formula group. When prompted, enter 2 and click OK. Click the Mixed Properties menu and select Freezing Properties Plot from the View group. Let's review the freezing plot for these two formulas. The y-axis shows increasing ice content, and the x-axis, going from left to right, is the temperature getting colder. The 3% fat formula has much more ice in it as compared to the 12% fat formula. Why is that? When we reduce the fat content from 12% to 3% fat, we lost 9% fat and gained about 9% water. We also gained about 9% ice since most of the new water is freezing. If our 3% fat formula is going to have a similar texture and mouthfeel to the 12% fat ice cream, then the ice content needs to be about the same. We need to find something to replace the fat as well as the extra water in the formula. This new ingredient must not be too sweet, not reduce the freezing point, and not change any of the other set properties. Let's go back to the formula development section and figure this out. Click the Formula Dev and Batching menu and select Formula Dev from the View group. We are going to add a maltodextrin to replace the fat. Click the Add Ingredients button, select maltodextrin 5-DE from the list, click the Add button, and close the window. Before we reformulate, we need to tell TechWizard our desired ice content range. Set the product frozen grams of ice per 100 grams T2 at 10 degrees Fahrenheit minimum to 46. Set the maximum to 46.5. Press the Formulate button. Let's rename this formula and load it in the Mix Properties section so we compare it with the others. Click the Formula Name and ID box. In the window that appears, enter 3% fat malto for the formula name and click OK. Click the Mix Properties menu and select Get Formula Information from the Formula group. When prompted, enter 3 and click OK. Click the Mix Properties menu again and select Freezing Properties Plot from the View group. Notice the ice content of the mixes. The mix with maltodextrin added has almost the same ice content as the 12% fat formula. Well, why is this? The maltodextrin replaces the fat and the extra raw water. This means less ice. This also means that before ever making this product, we know it has a good chance of having a similar mouthfeel and texture as the 12% fat ice cream. This can be a real product development time saver. Well, now that we're experts at manipulating ice, let's modify the ice cream formula further. Along with reducing the fat content, we will increase the protein content to 6%. We'll first need to go back to the formula development section. Click the Formula Dev and Batching menu and select Formula Dev from the View group. We need to inform TechWizard of our new protein requirement. Set the min and max for protein to 6. Press the Formulate button. Notice that TechWizard failed to find a solution. We need to determine why it failed. Click the Formula Dev and Batching menu and select Composition from the View group. This is the composition of each of the ingredients that we have added in the formula. Notice that condensed skim is the main source of milk solids not fat and protein. Click the Home button to go back. Milk solids not fat is limited to 11%. This means that to meet this requirement, TechWizard cannot use more condensed skim to increase the protein content. To have any chance of increasing the protein content, we must increase the amount of milk solids not fat allowed. Set the milk solids not fat max to 13. And press the Formulate button. Notice that the protein content went up slightly, but is still too low. Note that the lactose content is above 6%. Lactose can crystallize in ice cream during storage, so increasing the amount of condensed skim milk further may cause problems. We need to find an ingredient that is a source of protein and does not adversely affect any of the other formula requirements. Click the Add Ingredients button. Select Concentrated Milk Protein. Click the Add button and close the window. Now press the Formulate button. Notice that we achieved our goal of adding 6% protein. Well, let's rename the formula, load it into the Mixed Properties section, and compare it with the others. Click the Formula Name and ID box. In the window that appears, enter 3% fat maltoprotein for the formula name. Click OK. Click the Mixed Properties menu and select Get Formula Information from the formula group. When prompted, enter 4 and click OK. Click the Mixed Properties menu again and select Freezing Properties Plot from the View group. Our goal of reformulating for 3% fat and 6% protein is a success. The ice content of the 3% fat formula with maltodextrin, the 3% fat formula with maltodextrin and concentrated milk protein are so similar to the 12% fat formula that it's hard to distinguish the plots. Becoming a frozen dessert expert is in part about understanding and controlling how ingredients influence ice content. I think we've met our goal of demonstrating how to accomplish this.